There are two modes of running iWB: online mode and offline mode. In common situation, user can connect to the internet using data and services from central servers. This is called online mode. But while we fly to airport, which lacks of ground operational support, iWB can help us finish weight and balance without network connection. This is called offline mode. Offline mode provides our customer high flexibility for charters and temporal flights. The iWB provides seat management for the great pressure from large fleets. With seat management, we can set up central weight and balance office and regional weight and balance office flexibility and ordinarily. After logging, we can see the responsibility of the flight for this logging user and messages related to these flights. Messages include dead load, a new weight and balance request, and offload information. This is one of the numerous dynamic data exchange that iWB provides for central weight and balance office and ramp. iWB ensures the high frequency and security via ensuring data consistency between the central weight and balance office and ramp. iWB can acquire flight data by manually input or by data exchange form. FOC system. Now we create a new flight by manual. Payload receiving. In order to adjust to the different IT condition of different destination, iWB can receive payload by 5 different ways. Beside input payload from an iWB client, we can use website PDA to input payload, and we can receive payload by email and CTAR type B. Now we get a payload from an Excel attached in an email. Payload is over. Fuel information can be inputted to iWB manually or through data exchange form FOC system. iWB includes standard and non-standard fuel loading. If there are combination ULDs, OHG, ULDs, and ULDs which exists location, ULDs over station, ULDs specified in a location, in dead load, it needs to be locked at first. Now let's experience the exciting automatic loading. iWB generates a load sheet within 1 second. Considering contour limit, ULD location limit, and cumulative limit, DG limit, and other more than 12 types of limit. iWB also considers unloading sequence when it generates a load sheet. CG optimize. In order to economize the fuel costs for the flights, iWB provides the automatic CG optimize. User just needs to set up the target CG on the screen. Then, the system will try to adjust the load sheet to approach the target CG. According to the testing by Air China Cargo and the calculation that Boeing provided, iWB can economize up to 2% fuel cost for 777 and 747 compared to manual weight and balance. In order to enhance the safety of weight and balance, the system provides cross-checks, which requires another desk to finish weight and balance checks. All warning, mistakes, and data changes will be raised up in this step. Finally, we are going to send all these outputs out. The output includes loading instruction, both text and image version, LDM and CPM, CG envelope, e-balance charts, all these can be transferred to PDA, email, CTAR, Type B, and ARCARS. Web server, monitoring interface, web terminal. Users can monitor all flights by progress bars, and all status changing will trigger notices to the users. All operating can also be viewed through photos. The PC terminal is mainly used by load planners. The main purpose of the web terminal is by which the flight can be monitored and the payload provided by outstation personnel can be updated. What PDA can do are the following. First function collects the information of the pallets and container. Second, print the loading instruction, which can just be printed after cross-checking. Third, apply for reloading if needed, which may cause by position exchange of the pallets or containers, the error of data, unload of the pallets or containers.